On lesson 7-3, we have to determine whether certain triangles are similar to each other based on the similarity statements. And we are continuing the ratios that we learned in the previous section to determine if they are similar. In the first example, we are looking at two triangles that are joined together by vertical angles here. And we know that side WS is congruent to side XS, and in the smaller triangle RS is congruent to TS. Because we know that these two sides are congruent and these two sides are congruent, and then because of the vertical angles we know that these two angles are congruent, we can determine that these two triangles are similar to each other based on the side angle side similarity. We have to make sure that when we write our similarity statement, such as triangle RST is similar to triangle WSX, that we go in the right direction. So if we start with angle T, or let's go ahead and start here. If we start with angle R, we have to match it up with the same angle that is similar in the other triangle. So in this case, it is W. So start with R here, W here. If we work our way towards S, then we have to work our way towards S on the other one. And then back towards T here, and then X here. T is similar to X in this triangle. On number 2, we are given a few sides, and basically what I want to do first is to determine if these sides have the same ratios, and I've compared them. 9 over 12 reduces to 3/4, and then the 6 over the 8 also reduces to 3/4. So because we know that these two triangles are similar, and again we want to move in the same direction for both triangles. So if we start with A here, we want to start with P, which is the angle that is congruent to this other triangle here. And then if we move towards B, of course we want to move towards Q here, and then to C, and then towards R. And then because we know all three sides here, and we know that all three sides have the same ratio, we are using the SSS similarity. On 3, we have the same thing. I want to compare both sides to make sure that they have the same ratios, and you can tell here I've compared the 10 to the 15, and that gives me 2/3, and then I've compared the 14 to the 21, and that gives me 2/3. One other piece of information that is given to me here is the angle that is between the two sides on both triangles, and it's both 70 degrees. So because of the side angle side similarity, we know that both of these two triangles are similar. And again, if we start with S, we have to also start with J here, and then we move in the same direction there. If we mix up the letters here, such as if we go STU and then go J and then to MP instead of PM, that will not be a similarity statement because it's telling us that angle M is similar to angle T, which is not the case. M is similar to angle U. So we've got to make sure that these are written in the correct order. Number 4. We are given two angles, the right angle, of course, the right angle, and then we're given 30 and 60 here. If you do the math on this and do the 180 minus the 90 minus the 60, you know that this missing angle here is 30. Do the same thing here. Do 180 minus 90 minus 30. You know that this missing angle in here is 60. So therefore you have two triangles that are similar, and you know it based on the angle-angle similarity. And again, you start with the 90-degree angle, 90-degree angle, and then you work your way towards 60, 60, 30, 30. On the next 4 problems, not only are we writing a similarity statement, but we're also trying to find x in each of the following. Now, in order to do that, we have to create our proportions based on the sides that we know that are similar in order to find x. So in this case, I've compared side AC to side ED on the bigger triangle, and then I've compared BC, which is 12, to side EB, which is 15. And again, those sides are similar there. I do my cross multiplication, which gives me 15x plus 15 equals 12x plus 60 after I distribute there. And then once I get x of 15, I don't stop there because it's asking us to find the measure of AC. Well, we know AC measures x plus 1, so we substitute in our x, which is 15, into that x plus 1 equals 16. So AC measures 16. And then, of course, our similarity statement, if we start with A, then we have to start with D down here. And then if we move towards B, again, we move towards B here. And then move towards C, we move back towards E there. On number 6, we do the exact same thing. I'm comparing side NM to side KJ, 4 over 16. And then we want to do the x minus 3 over x plus 18. We're going to cross multiply and distribute on both of these. So we get 4x plus 72 is equal to 16x minus 48. We solve for x. X is equal to 10. And again, once we find x, we're not finished because the problem is asking us to find the measurement of J to L, which is x plus 18. So we substitute in our x here plus the 18, and it gives us a measurement of 28 for JL. Number 7. Now don't get confused just because these are put together. It's still the same thing. They are both similar triangles. You want to use HG here, which is 6, and compare it to FD, which is 12, and then set it equal to side EG, which is x plus 5. And then you want to combine E and D. So this is how I got the x plus 5, and then you have to add in this 9 to get the total side of ED. And then, so here, 5 plus 9 gives you 14. So once you distribute, you get 12x plus 60 equals 6x plus, and then 6 times 14 gives you 84. Solve for x. You're looking for measurement EH. We know then that because this is 9 and this is 9, then since this is x plus 5, this also has to equal x plus 5. So then I just substitute in my x for this problem here. So 4 plus 5 is equal to 9. And then similarity statement again, move in the same direction. Last problem, kind of like the last one. We're comparing VU, which is 6, to SR, which is 14. And then we're taking x plus 2 here. And then we want to compare it to the total ST here. So we have x plus 2 plus 3x minus 3. And then once you combine these, you get 4x minus 1, so that when you distribute, you end up getting 14x plus 28 equals 24x minus 6. And then you solve for x. You end up getting x is equal to 3.4. You're looking for VT, which is x plus 2. You substitute in 3.4 for your x, plus 2 is equal to 5.4.